Okay, I'm Sam Browne. I'm the DevSecOps lead for Trilinos. I lead what was formerly called the framework team. So if I use either word interchangeably, they're the same team. We're responsible, as stated previously, for all of the CI processes that enable all of the Trilinos software quality assurance. We also do a lot of work on the build system. It's kind of in the same general wheelhouse for familiarity with a lot of the developers that are on my team. And as Trilinos is transitioning to the high performance software foundation, we're placing a much bigger emphasis on the accessibility of collaboration, the ease of use of our CI tools and our build systems. So I've got two kind of somewhat disparate but related pieces to go walk through that. And then thanks to the members of my team for all the work that they've put in to make a lot of this possible. So the first thing we're going to run through is how our CI testing works currently. Trilinos uses a modified Git flow workflow for its contributions where developers constantly merge changes to the develop branch, and then the summation of those changes is merged to the master or the main branch about once a week. As part of this workflow, we have a number of different CI style checks. I put a fairly comprehensive list of them here. The emphasis is that some of them are required, not all of them are. Some of them are just informative as we stage them into required checks, or they might live there forever for things that are not as reliable. And the number one important one is this first bullet here that says a fairly comprehensive set of package builds and tests on multiple tool chains. We do on the order of 8 different tool chains and configurations for every commit that goes in. So the way that this works currently is we have pull requests sitting out here on GitHub, and then we have internally to our site a polling-based system that reaches out to GitHub, checks for commits that need to be tested, whether they have new changes or a user has explicitly requested that they be retests. It spawns a number of jobs, reports that it's spawned those back to the pull request via a comment, waits on them, and then reports back the status pass or fail. The important delineation here is this dotted line. Anything past this, pretty much nobody but my team gets to see, and especially nobody externally. So this can make it really challenging for people to develop and contribute, even inside of Sandia, because it's often not intuitive whether or not a build has failed because of a contribution or because of something that went wrong with a piece of computing infrastructure. So the operative premise or the thing we're trying to do as part of our HPSF merger is not really the right word, but join, is get that dotted line as everything as small as possible on the far side of the screen. So anyway, then this polling model launches the number of toolset jobs that check out our merge state, do the actual configure, build, and test, report the results out to a C- dashboard, and then report the status back to GitHub itself to allow for the merge. This is listed as user-facing right now, C-. There's kind of an asterisk here. This is user-facing for our internal users, but not for external users. We're working on getting that resolved. We are fully planning on this being accessible on the World Wide Web sometime in the next year, hopefully. There's a lot of security approvals to go through and policy things we're having to work on. But so that's how this currently works. And that other important thing is the thing in the middle of this auto tester box where it says it's limitedly controllable via labels on the pull requests. Developers can request that all of the testing be reperformed. They can tell it, don't want to run any testing. It's a work in progress, but it's very limited. That's the key. Okay, so here is how it's currently working with some of the new builds that we're starting up. You'll notice that right here, the dotted lines shift outwards, and all of this is driven via GitHub Actions. So this is probably familiar to anybody that's worked with any other software on GitHub. We're trying to standardize everything and make it as transparent as possible. So now everything happens in the GitHub Actions terminal, but we do still want to dispatch jobs to our internal build hardware because Trilinos is very expensive to build and test, at least compared to the rates that GitHub charges for their built-in runners. So now we still have our compute hardware over there on the far right, but now you'll notice some different icons. There's a Podman logo because these are containerized runners, and that's the very important point. And then there's this little AT2 logo. That's controlling that highlighted part that says check if the job can be run. I'm going to get into that on the next slide. That's the part that is still somewhat Sandia specific or any internal site specific. After that, it's largely the same. We check out the merge state, do the build, report the results. I did add a little icon on this in subsequent slides showing that we have a persistent Ccache object storage to accelerate builds. I have a brief slide on why that's important. But the key thing is we push the dotted line over to the right. People can still see some of the raw build output this way. So as far as checking if the job can be run, this is probably the single most important slide for any external contributors, is why is their job running or not running? Pretty simple decision tree. We have a GitHub team called pretest inspectors. That's effectively people that can run jobs on Sandia hardware, or they can approve other people's jobs who can run on Sandia hardware. So you can see if they're a member, we go on to the next phase. If they're not, then we check to see if it was approved either via some sort of label or an explicit code review approval. And then it also needs to, currently the action needs to be triggered by a member of that group. I think we are working with the Autotester 2 team to remove that requirement so that it will work much like the old system did, where any Trilinos developer, internal developer, can go apply a label to the pull request and then it'll be tested by any rerun of the job. But anyway, if it doesn't pass that, we refuse to run the job. There's an additional check that we had put in, which is we wanted the more CI savvy expert team, our team in this case, to be able to, or to have to approve any changes to the CI workflow itself, the .github directory. So we have a special approved by label that has to be applied by somebody on my team. But if your job isn't running and you've contributed, it's probably because of a failure on this diagram. Reach out to an internal developer. We tried to put informative error messages into the console so that it hopefully is obvious what's happening, but they are still somewhat buried down in the actions console. I'm not going to talk about this a lot. This is a brief graph of why we need Ccache object storage. This dark purple line that's oscillating up and down on the left, that's our CUDA build. We realized that we did not have our object cache mounted into that container until right about the end of March. We mounted it and suddenly the CUDA builds dropped in expense by probably about 80%. So we get about a 91% hit rate run to run. It's extremely important to us to keep this for CI efficiency. So here's how this could work without Sandia resources. Note now that there is no separation. All of this occurs in the open. Granted that the runner, the containerized runner we have, is running on some open hardware, wherever that may be, cloud or otherwise. The only other difference here is I've changed the Ccache object storage to use sccache, which is a cloud-based backend model for storing Ccache objects. You can use S3 or other cloud backends. So this is where we'd like to go long-term, hardware permitting. And then finally, I put a concrete example of what this would look like if we leveraged, for example, the Frankenstein machine at University of Oregon. You can see there's still a little internal piece over there on the far right where we have some either the current mirroring scripts that Ketware has maintained, or we have long-term a product like Hubcast that mirrors our GitHub jobs into the University of Oregon GitLab. And then we can run on some of the more bespoke hardware, but at the same time more accessible that they have there, like things like AMD GPUs or Intel GPUs. Okay, so as far as where we're going, encapsulating the build and run environments as containers has been really immediately beneficial for us. I glossed over that a little bit, but now I'll call out that this allows external customers or internal customers to reproduce the exact environment that we're testing in. We can't distribute the container images yet, but the Docker files themselves are all out on GitHub in a project right next to Trilinos. So if anybody wants to reproduce the environment or just wants an environment in which you can build Trilinos, which can be relatively complicated if you have a lot of the TPL stack turned on, you can grab those container Docker files yourself and build them. They should build just fine. If they don't, we'd like to hear about it because we took pretty strong pains to make sure that you didn't need anything internal to our network to build them. The hardware is a different story. You'll still have to have a GPU machine, but that's probably less of a lift. We still want to work on accelerating the CI, build and test-wise. This focuses on build, but we have other back-end work to do to optimize the tests. We're looking at doing per-package binary caching with SPAC. This would combine with our Ccache approach to hopefully give us 2 layers of caching and accelerate things as fast as we can. And then for the next part of my presentation, we want to make the configurations as easy to understand and interact with as possible. So I have a very accurate quote here. I checked this with the leadership team, and they all agreed that this was, even if it's not exactly accurate, it's pretty close based on all of our user surveys. Trilinos is extremely complicated or perceivedly difficult to build. And that's largely because we have so many different configurations possible. People can't figure out exactly what it is they want and then manage to get a combination of those options working together, particularly for some of our internal codes that use a lot of different Trilinos packages at once and have to configure a lot of them. So what they typically do is they get a set of configuration options that work, and then they never change them, ever, under any circumstances. They put them all into a shell script, and that is the one way they build Trilinos. So the funny thing is, you can actually see this in our own CI configurations. We passed 250 options to CMake in one of our example builds. I think this was CUDA in the old system, and 200 in our new configuration with the container. We're trending downwards. We're getting a little better, but it's still a pretty tough pill to swallow for most casual users, if you will. So I'm going to look specifically at reducing 2 of them right here. We're going to gloss over these, but I'll explain why. We're going to look at the TPL-related options, because those are probably the largest magnitude, and then the global or package-level configuration options, and say, do we really need to be passing all of these? And if we do, can we make it so that we don't? So for third-party libraries, this is a pretty system-dependent problem. If a user only has one LAPACK installation, they can probably just turn LAPACK on, and it will probably be found correctly, assuming that it's a normal implementation. But if they have several and they have a specific one they'd like to use, this is a place where it may be necessary to pass additional configuration options. I'm not certain how much we can get rid of that, or we can get rid of the fact that they'll have to pass something specific. We can minimize it, but it's still going to have to exist. The new CI testing containers only have one installation by design of all of our TPL, so it really, for the most part, is as easy as just turning on the pieces that we want. We would like to explore, I don't know if correcting is the right word, but choosing a sensible set of default enables and disables so that people don't even have to know that, right? If you enabled one package, the default is to turn on this TPL, even if it's optional because we think most people want it, or we have data to indicate that most people want it. So we're going to try that. Last note I'll make is that moving towards the standard find package approach within CMake, as the CMake package config ecosystem matures, and this heavily ties into the usage of SPAC, this should make this a lot less complicated. We want to preserve the ability to be more specific and pass additional options if we have to, but we'd like to leverage this as much as possible. So that covers the TPL options. Package disables, I'm going to say, are completely not a problem. All of those are related to our deprecated package stack that Kurt talked about. Those will be gone by the end of the year. We won't be passing any more off settings. Test disables is the 4th category. Generally, when we disable tests in Trilinos CI testing, it's because the test exhibits unstable behavior when running in a CI context, or maybe in all contexts. But the developers usually say, well, there's value that's provided by that test, especially when we're working interactively, and we can make a qualitative call on what we should do about that. But from a CI context, they agree it's not something we don't want flaky tests, so we turn it off. So we're not going to address the scope of that for now. The final one I think we can minimize is what I'm calling global or package level configuration options. I have a demonstrative example in the middle here where this is from our configuration. We turn on CUDA. We then tell Cocos to turn on CUDA, and we then tell Phalanx that Cocos should be using CUDA. I'm asserting that this is silly. We definitely should not need this. We might need it. I haven't gone into this, but this is one where we're going to go and say, we should be able to cascade these down and have the users can just say, I want CUDA turned on. Or perhaps I'm using the NVCC compiler. I'm going to assume I want CUDA turned on, for example.
So would the idea being you say, TPL enable CUDA, and then whatever Phalanx's default would be like, oh, I should look at TPL enable CUDA before I set whatever my...
I see that CUDA's turned on, so I'm going to change my default to that device type. Right. I have absolute confidence that this one probably already works, but that gets down to my last one. If we're passing, why are we passing these if they're to the default? The answer is probably that at one point it didn't work, so somebody said, I'm going to fix the CI configuration. I'm going to nail it down so that it's always working. But what that does is it has the effect of never testing our default. So we don't actually know if it'll work without all of these complicated options. So what we've done is we backed ourselves into a position where we have to pass, or we imply that we have to pass 250 options to configure and build Trilinos, and that's not really a great experience for the developers or the users. So we want to test the defaults wherever possible, and our approach should be to make the defaults correspond to what the majority of our users want when they configure and build Trilinos. So if anybody's heard of SPAC, SPAC is really great at abstracting some of these packages that have a lot of CMake options into variants, and that's a fantastic approach. It already happens. We only have 80 variants compared to most other packages. That's a lot. And 30 of them actually relate to turning on and off our non-deprecated packages. So this is where it can be complicated for first-time users that want exposure to Trilinos. I'm going to assume that they're building it through SPAC because that's a fairly accepted way to get software on HPCs. They might say SPAC info Trilinos, and they see Trilinos with 80 variants, and they're not sure exactly which ones to turn on or off, or what they're going to get with the default build. So what we want to do is we want to represent that nicely from a user experience perspective while preserving the ability to have Trilinos be configured at the current level of granularity. So what we're looking at doing is modeling Trilinos within SPAC as individual SPAC packages. So I have an example translation here right now. If you turned on Staccato and Mulu, and then you also wanted to build for GPUs, this is what it would look like. That's what it would look like in the future. Or if you only wanted Mulu, for example, you could just say SPAC install Mulu plus CUDA. There would be other options controlling the build parameters. There's a lot of machinery to get right to do this correctly and have everything hook up and set the inter-package dependencies correctly. We do have a limited example of this with Cocos and Cocos kernels. If anybody knows, if you build Trilinos through SPAC, you only get the external Cocos and the external Cocos kernels. But this is only for snapshotted packages. So doing it with internal packages is a little bit more complicated, but we have pretty good confidence that this is going to work. The SNL Sierra code, the multi-physics code, is using this exact approach where they maintain one mono repository still for compatibility interconnection, but they model the SPAC packages separately. So we're leveraging work from that. Joe's actually the one doing this work if anybody has specific questions. But Phil is going to give a pretty detailed presentation about that tomorrow at 4:40.
So this isn't so helpful, though, if we have fewer packages, right? You still have to use the variants, which I think is the direction we probably need to go. We probably don't need 15 solver packages. We probably need like 1 or 2. Then you'd still have to use
That depends on how few packages you have. I'll assert that if you have more than 5 packages, this is probably still pretty beneficial. It's hard to know because I'm very comfortable with the Trilinos build system, so it's fairly, and I know the names of the packages. That's a big one. If somebody looks at it right now,
still need to have the variants to like, turn on the features within the package.
oh yeah, but those would look very similar between a lot of the packages, at least where they're currently global options for Trilinos. So the whole point is that the variant language for the individual package should be more expressive than it is now. Right now, when you look at Trilinos's variant breakdown, it's a lot of words that people probably don't understand because they don't know the names of the Trilinos packages. And then words they do understand because, well, it's obvious what the difference between like single and double precision floating point is, that type of thing. Well, I don't know if it's really obvious, but it's more obvious than what Staccato is to the uninitiated. So there will still be the same level of problem space complexity. It's just going to be represented. It's going to be represented a little bit more granularly at the top level. So to finish up, we're trying to take advantage of as much open source and common CI infrastructure as we can. We want Trilinos development and use to be accessible to the open source community. We really want to minimize our configure option spread, and the SPAC Trilinos interaction is being worked with a pretty high degree of urgency and care because we recognize that a lot of people use SPAC to build software and they'd probably like to use Trilinos to do it, at least from a casual user perspective. So. And then I did have one more thing that's not in my slides, which is Samir had pointed out. These are all the different architectures that E4S tests Trilinos with nightly. So it works on a lot of different computing platforms. These aren't in our CI, but we do get a lot of benefit from them doing the nightly testing and bug fixes. So that's all I have.
Thanks.